Okay, here's our problem. It says 120 volt, 60 hertz source drives a load equivalent of a 75 ohm resistor in parallel with a 25 microfarad capacitor. Determine the appropriate capacitance or inductance value to place across this load to produce a unity power factor. So let's just draw it and see what they're talking about. I got a voltage source, it's 120, and it's at 60 hertz, right? I'm going to convert 60 hertz automatically to radians per second because that's what we're going to need. So I'll take 60, and the hertz is cycles per second, so it's cycles per second. That's 1 hertz. It's 1 cycle per second. Multiply in 1 cycle. There's 2 pi radians in 1 cycle. So now I get radians per second. That's going to be 120 pi radians per second. All right, cool. So now I know what my frequency is. They don't tell me anything about it being offset by an angle, so I'm just going to make it angle 0 because it's hertz. I know I'm going to be doing a alternating current. So we got a load equivalent 75 in parallel. All right, so here's my load. It's a 75, and it's got to be in parallel with the capacitor, right? So let's see. They tell us that the capacitor is 25 micro, but since I'm in AC, I'm going to convert that to its to the phasor rendition. So 25 micro. Remember, that's equal to C, but you got to remember Z of a capacitor is going to be negative J over WC. So it's got to be negative J over W is 120 pi, and then C is 25 micro is 10 to the negative 6. That number ends up giving you negative 106, and that'd be J. So that's going to be my capacitor. So I'll put the negative 106 J. Bam. So now I got my alternating current values. So now I got to figure out what capacitor inductor to place across it, right? So this whole thing right here is my load. All right, so if I want to place something across it, that means I'm going to put an inductor or capacitor there. If I want unity power factor, I want balance, and the only thing that a balanced capacitor is an inductor. So I'm going to figure out what value this is. I don't know what the inductor is, but I know I got to put an inductor there. So let's try to work it out. Well, they want unity power factor, right? They said it here, unity power factor. So let's figure out kind of what that is. Power factor equals the cosine of the angle from the voltage minus the angle from the current, right? And you want it to equal 1. So cosine of what equals 1? Cosine of 0 equals 1. Therefore, the angle of the voltage source minus the angle of the current coming from that source, that will basically be the current and the voltage associated with this guy. That's going to be where the power factor is coming from. That has to equal 0, right? Well, if you look at the angle from the voltage is already 0. Therefore, what I'm really trying to say is that since the angle of the voltage is equal to 0, that means that the angle of the current has to be equal to the 0. Right? The angle of the current equals 0. That's what I want. Okay. So if I can figure out the current and I can set its angle equal to 0, then I can kind of make this all work out. I put L here, but I'm actually going to erase that. I'm going to put what its Z equivalent would be, which is JWL, right? And I know W is 120 pi, so I'll put J 120 pi L. So I'm just looking for that L value. So there's a lot of different ways to kind of solve for this. I actually tried to solve this before, and the first thing I tried to do was combine all these guys and then try to find the current based on that. That's a pain in the butt. There's a couple different ways to think about it, but I'm going to do the way that makes the most mathematical sense. I could do all the concepts, but then I think I kind of had to do a skip hop, and I didn't really feel comfortable trying to talk about that. So what I'm going to do is I'm going to find I. I'm going to find I using superposition. So I'm going to say I equals I through the 75 plus the I through the capacitor plus the I through the inductor. Okay. So you got to think about what these values in themselves do. Like now that I've isolated each of their effects, right? It's gonna be, you got to think about what each value brings. Like for example, resistors always have an angle of 0, right? So that means the current through that resistor also has an angle of 0, especially since the voltage is at an angle of 0. Capacitors always have an angle of negative 90, and inductors always have an angle of 90. And so what happens is, if I look at just the resistor, it's not going to affect anybody because this angle is 0. It can't offset anything because it has no angle with which it has the power to offset any signal. Basically, what I'm trying to say is if you have a purely resistive AC circuit, all of your output signals are going to have the same phase as your input signals because resistors don't change the phase. That's what I'm trying to say. Capacitors and inductors are the guys who change the phase. So basically, I can effectively, I'm not writing this to 0. I'm just saying I'm not going to consider him when it comes down to finding unity. Unity is going to come from the guy whose angle can be made 0. The only thing that can change the angle of the capacitor and the inductor. So that's what I'm going to focus on. So basically, the current through the capacitor is just going to be, if you note that this voltage is sitting exactly on that guy, I could say that the current through the capacitor is going to be equal to it's V over Z. So it's going to be 120 angle 0 divided by the capacitor, which is 106. Negative 106J is the same thing as 106 angle of negative 90. So I'm just going to write it in its polar form, just like that. And so that's going to be, I don't know what 120 over 106 is. I don't really care. That's some number. The point is that I have an angle of 90 here. So that's going to be the effect of that current, right? So the current after it's passed through the capacitor has actually flopped, right? The value of the current versus the voltage is actually flopped by 90. That's what I mean by voltages. I'm sorry, angles are changed by the capacitor and inductor. So now I can see how the inductor will change the current. So IL will be 120 angle 0. And now I have 120 pi, and the angle has to be, can't forget my L. L, that's the variable I want. And the angle has to be 90, because J is just an angle of 90. And so from this, I see that I'm going to get the 120s cancel. So I get 1 over pi L, and the angle will now be negative 90. All right, great. So the whole idea is that these two guys are going to add up, and their angles have to equal 0. So when I add those two angles, when I add these two guys up, their angles have to equal 0. So 120 over 106 angle 90 plus 1 over pi L angle negative 90 equals some number. I don't care what the number is, but I want the angle to be 0, right? So considering that an angle of 0 basically is purely real, right? So you have to think about that. Angle of 0 is pure real. If it's pure real, and an angle of 90 is pure imaginary, that only means one thing, Ari. That only means one thing. These have to cancel. So what I'm trying to say is these guys equal each other because they have to cancel. So 1 plus another equals 0. This negative 90, you could rewrite it like this: 120 over 106 J minus 1 over pi L J equals 0. That's basically what I'm trying to say, right? Because I have a plus J and a negative J. The negative is going to come from the fact that I had a negative 90 there. All right, whatever. So all I'm trying to say is 120 over 106 equals 1 over pi L. All of that was just to say that I can solve for L. L is actually going to end up being the same value of the capacitor, which is 106J. Now, for those of you who are like super conceptual, the easiest way to say this is for a unity power factor, the capacitance and inductance have to balance out. Since they're right next to each other, basically the capacitor is 106 negative, the inductor has to be 106 positive. Actually, that's the Z on the inductor. I messed that up for a second. That's the Z on the inductor. So let me undo. I got to find the actual inductance value. L is going to be because 120 pi L has to be 106. Therefore, L is almost messed up. Everybody and their mamas. Let's see. The Z on the L has to be 106. L in itself is actually going to be 0.2811. Almost killed everybody. 2811. That's going to be the value of L. And it's going to produce a Z, which is 106. There we go. Almost. Ruined that. But yeah, they have to balance out. Therefore, if the capacitor was 106, then the inductor has to have a Z of 106, and you could just say 106 equals JWL and solve it from there. That's the conceptual way, which is a lot simpler. But I wanted to have kind of a bit of math behind it because sometimes your concepts could have a mistake in there, and You always want to be able to back your math up with your concept and your concept up with your math. So here's your math way and then a concept finalization. So with that being said, hope this helped.